So I want to talk to you about, it's a continuation of yesterday. Yesterday we talked about relation. Okay? By the way, you know what a relation is? What did I say yesterday about a relation? How do you have a relation? A group or a set of pairs. So what do you use correctly? A set of pairs, order pairs, right? Describing or at least trying to describe a situation. And yesterday, we're using a set of order pairs to describe the number of blue triangles for each iteration. Is that true? So it has to have a purpose too. You don't just give me a bunch of points and say, yeah, that's a relation. It has to have a purpose. And now, I want to introduce something that is it's a relation, but it's a unique relation. It has its own characteristic. Just like if you're going to buy a car, if you're going to buy a Lexus, you expect a certain characteristic to have for a Lexus. For example, first of all, if you're buying a Lexus, what do you expect to have? Do you know what a Lexus is? Okay. It's a car, but yeah, exactly. Relation is just like a car, but then we have so many different kinds of cars, right? So if I'm saying I'm going to buy a Lexus, what do you think I want to buy a Lexus for?
For a car.
I don't know.
First of all, expensive, luxurious, okay? And if I'm saying tomorrow I'm going to go and buy a Lamborghini, okay? What's special about a Lamborghini?
It's expensive.
Okay, first of all, it's expensive, extremely. But for guys, why are you buying a Lamborghini? Fast.
I don't like
You see that? That characteristic defines what a car is. It's a fast car. Expensive, fast, and it has other characteristics too. But I can't mention it here.
Just say
No.
it.
Okay. Now you can research. But that's what the whole point is. For today, I want to introduce to you a different kind of relation, and that particular relation is called a function. Right there. So this right here, guys, is a special relation. It has this very specific characteristic, and I'm going to talk about that right now. And the characteristic for this special relation is its truthfulness. I hope I can spell that right. Is it 2L or 1L? 1L?
Yeah.
Okay. Because of its truthfulness. So today, I want to teach you the art of being truthful. How many of you here have lied in your life? All of you.
Raise your hand if you have.
Typical, it's so typical. But for you to recognize this special relation, you need to be able to distinguish whether something is a lie and something is something that's true. Okay? My best example really is an example of a relationship, which ties into a relation. I'm sorry for bringing this up, but this is what's happening. Let's pretend me. Wait, why am I using me as an example? Fine, me. I met this lady. Okay. Okay. So I asked her to be my girlfriend. Fine, done, right? Okay. So we're a couple, right? But then next week, I met another one. So, what does it mean?
You're going to get cheated.
So, I'm a cheetah, huh? I'm a cheetah. Not good. Okay, yeah, you can call whatever you want. But socially, that is unacceptable. Is that true?
Yeah.
Same thing in mathematics. Believe it or not. You cannot have the same number go into two different numbers. Same thing in life where I cannot have one person meeting two different other people. You know what I'm saying? So let's go back to math a little bit and show you what is unacceptable. For example, pretend I have this set of relation. This relation. 3, 2, 4, 3, 5, 7, 3, 6. What did you notice about this relation?
The 3 in the x coordinate is a duplicate.
Ah, look at the 3. It's going behind the 2 and meet up with the 6. Cheater, huh? Cheater? Did you see that? Did you see that tricky 3? Look at the 3. Okay, so in mathematics, when you ever see a case like this where the number is cheating with other numbers, it's unacceptable. Therefore, That's not being truthful, and if you're not truthful, we call this an invalid or not a valid function. Not a valid function. Because if it's a valid function, we should be able to see just 1, 3 go to one number and not different numbers. Okay? Because it's staying true to that same number throughout the set. Okay? So that's one way to look at it. And we just caught the 3, red-handed, going with the 2, going with the 6. Not good. I don't like that. Okay? Now, so this is just how we see, all right? Just to validate a function. Another way to validate a function is by using a mapping diagram. So let's do a mapping diagram quickly here. Yesterday, I taught you that to do a mapping diagram, you have to do what first? Do columns, right? Domain and range. So here's my domain, and here's my range. On the domain side, what do I have?
3, 4, 5.
3, 4, 5. No duplicates, remember? So 3, 4, and 5. For my range side, what do I have? 2, 3, 6, and 7. All right, watch what happened. For the 3, it goes to the 2. Good couple, right? Aw, I know, right? So everything's perfect at that point in time. The 4 with the 3, good couple. They're all good. Perfect. 5 with the 7, right? It's all good. So far, 1 pair, 3 pairs total, right? And all of a sudden, 3 with the 6. Uh-oh, right there. Got caught. Doing what? Cheating. So because of that, we immediately invalidate this function saying, not valid. That's how we know. Okay? So you might want to say, so it always start with the domain. The domain, why? Because domain is also known as the independent. That is the one that starts it all. Is that true? So therefore, when we try to validate a function, we always look at the domain. Are you being truthful to me, domain? If you're not valid. That's what's happening. Ask yourself that question. Just approach the problem saying, domain, are you being valid to me? Are you being truthful to me? Okay, so that's one way to do it. Hold on. One more way to validate this is by actually graphing. Watch this. If I put this up using a coordinate plane and plot every single point. 3, 2. So 1, 2, 3, go up to 2. 4, 3. So it's going to go 4 and 3 up. What else? 5, 7, right? So 5, 4, 5, 6, 7 right there. And I also have 3, 6. 3, 6 right there. This method is called the VLT. It stands for the vertical line test. Whoa. All right. Okay, let me try that again. This is called the VLT method. It stands for vertical line test. What it really does is, if you actually take a ruler or maybe draw a straight line, if your ruler or the straight line that you're going to draw crosses through one point at a time, then it's perfectly normal. However, if your straight line or your vertical or your ruler crosses through 2 or more points at a time, that's invalid. Why? Watch this. Look at the 3. Crossing over 2 points. Just like how you see it on your mapping diagram. Just like how you see it with being duplicate here. That's why you see it here on the graph as well. So what I'm showing you is that I have 3 ways to validate a function. In this particular case, I managed to say that this relation right here is invalid because, first of all, I see duplicate pair inputs on the domain. I also see this using a mapping diagram that the 3 has 2 different values. Go to 2 different values. It's cheating on the 2 and the 6 at the same time. Not good. Over here, you can also see the 3 is going through the 2 and the 6 at the same time. Okay, so this is 3 different ways to do the exact same task, but I need to make sure that you know how to validate. If in case I ask you to do a mapping diagram, you know how to do a mapping diagram. If I ask you to do a graph, you also know how to use a VLT to test it. Okay, go ahead and ask a question. Yes?
Would it also be not valid if the range had a duplicate?
Okay, good question for that, which I'm about to bring that problem up right now. Okay, so so far I said that it's not okay to have duplicates in the domain. We cannot have that case, right? Now, Jennifer asked, what happened if I have duplicates range? Is it okay? So let's bring up another example that has duplicate range. Here we go. Pretend I have 3, 5, 2, 5, 1, 5, 0, 5, right? Duplicate range, is that true? But they all have different domain. Okay, so if I do a mapping diagram on that one, it will look something like this. 0, 1, 2, 3, 5, and your graph will look like that. If you do an actual graph and plot the points, you'll see this. 0, 5, right here. 1, 5, right here. 2, 5, right here. 3, 5, right there. Okay? And if I use a vertical line test, it's crossing through one point at a time. It did not break the rule, right? Because the rule says if it crosses through 2 points at a time or more, it's invalid. But this one only crosses through 1 point at a time. Notice that the 0 pairs with the 5, 1 with the 5, 2 with the 5, 3 with the 5. Okay, so you tell me, is this valid or not? Let me tell you right now. It is perfectly valid. Let me tell you why. So this whole thing is valid because of this particular reason. Let me ask you this is a real life question. How many ways can you make contact with your friends outside of this class?
1, 2.
Okay, first way.
Oh.
Phone. Second way.
Computer.
Computer. Interface, meaning you go online Facebook? Okay, third way. Twitter, fine.
Twitter. FaceTime.
FaceTime.
Tumblr.
Skype.
Email.
Email. Google. Or yeah, you can actually Google chat too, yes. Yahoo Mail. So, or you can just go to your friend's house. Right? So, notice, you can actually give me like 10 different ways to achieve what? One thing. This is what's happening. I can have so many ways, but I only have one output. You see it? I can say, I have so many ways to meet my friend, but meeting my friend is what I want to achieve at the end. Input, output. Okay, so your intention is, I want to meet my friend, right? How many ways can I do it? I can have many ways to do the same task. So it is okay for you to have multiple domains go to the same exact range, but not the other way around. Why is it not working on the other way around? Because think about this. Think of it a real life example. If you take out your phone, right, and you dial 5, you expect to see a 5. So that means if you translate that into a point, 5, comma 5. Is that true? But now if you take your phone out again and dial 5 and it appears as 6.
What?
Then what's happening? Is your phone functional anymore? That's why it's not functional, it's not valid. See, so that's why it's not okay for you to have the same domain go to different outputs. That's why. Okay? Yes?
Would it still be valid if the domain was 5 and the other numbers were 3?
What is it?
Would the whole thing still be valid if
Okay.
5 was the domain and the others were the range?
You mean just one? You mean 1, 5 over here going to different outputs? What did I say about that? Can you actually do that? Is the 5? So you tell me that it's okay for you to punch in a 5 and then it appears to have a 5 first time around. Punch in a 5 again, it's going to be 6. 5, it's going to appear as a 7. 5 appears as an 8. Is that valid? No. You see that? That's what you need to think about that for a minute. So it's not okay to have duplicate on the domain, but it's okay to have duplicates on the range. So that's my final conclusion on this piece. No duplicate on domain, ever, if you want to call this a valid function. If you ever find any duplicate on the domain, it makes it invalid right away, for good reasons too. Okay? Now let me ask you, do you have any other examples to demonstrate this case, where you have multiple inputs going to the same output? Besides, I gave you an example of contacting your friends. Okay, is there an example? Yes?
Ways you can pay for things?
Yes, you can pay for things. Ways that you can pay for things. You can write a check. You can credit card, cash. There you go. That's an example. Very good. What else? Give me a brand new example.
Stores.
Yes.
How to come to school.
Exactly. You can walk. You can run. You can hitch a ride with someone.
You can skip.
You can skip school. No one had to get to school. So, yes.
Stores in a mall.
Yes. Okay. But do you notice the difference between having duplicate domain and duplicate range? Okay. Any questions so far? Yes.
Is it kind of like different methods to do something?
Yes. The same exact. Yes, you're right. So this whole lesson is about, hey, we have different ways to achieve the same task. It's definitely normal, right? But it's not normal to say that I have one way of doing things, but it gives me different outputs all the time. That means something is not right about the machine, right? If you expect this machine to make cookie, and one day it's making cookie, and the other day it's just making cake, that's not what you expect the machine to do, you know what I'm saying? So that's what's happening, okay? Any questions so far at all? We good?
Yeah.
Okay, so that's it with our lesson for today.